Arrays provide a lot of power for working with larger amounts of related data. I have an application here that has 5 names that have been inputted through 5 input boxes, and I want to be able to alphabetize those. Well, let's assume first that arrays don't exist, and I need to place these into variables and then alphabetize them. So I'm going to show you the code that I have for this button that will alphabetize these 5 names, treating them as separate variables. So I have a button with an event listener, and my first button is going to alphabetize them by variables, and it's calling a function called alphabetize1. And here is my function alphabetize1, which is going to sort these unlinked variables. So first thing I'm going to do is read those 5 input boxes, the text of those input boxes, into 5 string variables. I've named my variables student 1, student 2, student 3, student 4, and student 5. And so I want to take those 5 variables and sort them and then be able to list them in this list box or this text box named alphabetical_txt. So the way I'm going to do that is take the very first variable, student 1, and I'm going to compare it to student 2. And if student 2 is less than student 1, I'm going to place student 1 into another variable called temp, and we'll make that a string variable. Then I'm going to place student 1 into student 2, and then place temp into student 2. So in essence, I'm swapping those 2 values, student 1 and student 2, if student 2 is less than student 1. Then I have another if structure here. Now I'm going to compare student 1 to student 3. And if student 3 is less than student 1, I'm going to swap those 2 values. And then I'm going to compare student 1 to student 4. And if student 4 is less than student 1, I'm going to swap those 2 values. And then I'm going to swap or compare student 5 to student 1. If student 5 is less, I'm going to swap those 2 values. At the end of executing these 4 if structures, what will have happened is the lowest value of the 5 alphabetically will be placed in my student 1 variable. Now I need to find the second lowest. And I'm going to do that by comparing student 2 with student 3. And if student 3 is less than student 2, I'll swap those 2 variables. And then I'll compare student 4 to student 2 and swap them if I need to. And then finally student 5 to student 2, and if student 5 is less, I'll swap those 2. At the end of having executed those 3 if structures, I now have the lowest 2 values in student 1 and student 2. Now I need to find the third lowest. And I'll do that by comparing student 4 and student 3 and swap them if student 4 is less. And then I'll compare student 5 to student 3 and swap those if student 5 is less. And now I've got the first 3 in alphabetical order. And the last thing I need to do is simply compare student 5 and student 4. And if student 5 is less than student 4, I'll swap those. At the end of that, my 5 values are in alphabetical order. Let's just test this. And there they are: Alex, Barbara, Kathy, Denny, and Edgar. Now going back to our code, that was a fairly long function. Took me about 75 lines of code to write that. Not horrible, but what if I had 10 names to alphabetize, or 50? This would be several hundred lines of code. And the chances of me making a mistake are pretty high because I'd probably forget to compare 2 variables. So not the best way to work with related information by placing them in variables and then trying to sort them. Here's where arrays come to the rescue. So I have a second button which calls alphabetize2. Alphabetize2 runs this function here, and you can see it's much shorter. It's only about 20 lines of code. And this would work not only for 5 students, but would work for 10, 50, 100, 500. Of course, I'd have to read each of the input boxes into an element of the array. So that would take more lines of code, depending on the number of input boxes I had. But if we were reading this in from a data file where I wasn't having to use these 5 lines of code, the rest of the code would work for however long that data file is. Now the algorithm I'm using here is called a bubble sort. And it works great for smaller amounts of data. If we start getting into several thousand elements of data, it might take a minute or two for it to sort. Not the fastest method out there as far as sorting. There are better algorithms. But the bubble sort's an easy one to understand because what we just did with our variables was in essence a bubble sort. We compare the first variable to all the ones below it and swap it if necessary. We compare the second variable to all the ones after it and swap it if necessary. And so forth with the third and the fourth and the fifth. And that's what I'm doing here, so I'm going to do it through a series of nested loops. My first loop is looking at I going from 0 to 4. Or actually from 0 to 3. It's less than 4. So I'm looking at these 4 elements. And each one of these then, starting out with 0, I've got a nested for loop here that's going to go for j equals I plus 1. So I'm going to start with the element after 0 and go to the very end. So when my I loop executes once, I will have compared element 0 with all the other 4 elements. And it's easy to do that with this array because all we're referring to is elements. I don't have to worry about the variable names. And then my outer loop goes to 1. I'm going to compare element 1 to the ones that come after that, then element 2, and so forth. So like I said, this would execute regardless of how many elements there were in our array. So I've started by creating this array. I've populated the array elements using my 5 input boxes. I have a variable called temp again that I'm going to use for swapping. And then there is the routine, that my nested loops that swap all the values that are alphabetical. I'm going to clear my text named alphabetical_txt. I'm going to use a loop to write out the values for each of the elements in order. And I've got a new line character here, so there's 1 per line. So let's watch this run. Same values, and there it is alphabetized. So a much shorter block of code, and if we added more names to be sorted, this really wouldn't change any except for adding in more elements to the array. But it gets better. There are times when working with, say, parallel arrays, we have 2 arrays that are associated together, where you might need to write a bubble sort. In some languages, you have to do some type of sorting algorithm. ActionScript arrays, however, have this really cool feature, and this is the third method I'm going to use. I'm going to again read all of my data into an array, placing the 5 input box text values into 5 elements of the array, and then look at this. I simply call the name of the array and execute its built-in sort method. That will sort these alphabetically. And then all I'm doing is displaying my text. So this, in this third routine, replaces this in the second routine. Everything else is identically the same. But it doesn't matter if I've got 5 elements, 500 elements, or 1,000 elements. This would sort the entire array alphabetically. Let's take a look at this and see if it works. So here's my third method, alphabetize array 2, and there's my names. Now I can put some parameters inside the parentheses of the sort method, and I could simply say array dot descending. Let's test this again. And now it's going from Z to A. Now what if I have numbers? I'm going to go ahead and get rid of that array dot descending. Go back to just the sort. I'm going to test my movie again. So I'm going to put some values in here. some numeric values. And I'm going to sort these. Uh-oh, it didn't really sort those numerically. It sorted them alphabetically so that 10, 11, and 12 all come before 2. And I really wanted to sort these numerically. So if I know my array contains numeric data, remember arrays are treated as strings, but if I know they contain numeric data, I can also specify a parameter in the sort method of array.numeric. And now I'll test it again. And this time put the same data back in. And now they're sorted numerically. If I wanted to sort those descending numerically, well, I could do that. Go back to my actions, and I'm going to add a vertical pipe. That's a shift \, vertical pipe character. And then I'm going to add another parameter here of array.descending. Notice there's also an array.case insensitive. So if one of my names didn't start with an uppercase letter, it would go to the bottom of the list because it's going to sort them based on the case sensitivity, and uppercase comes before lowercase. If I wanted to take that out, I could do array.case insensitive and remove that restriction of sorting them based on the case. Okay, so now I've got a numeric array that I want to sort descending. Again, I'm going to test this. Go back, put my same data back in that we looked at earlier. I'm going to click alphabetize array 2, and now it's going from the largest to the smallest numerically. So let me go back and take a look at that case insensitive. I'm going to go ahead and get rid of those two parameters. And now let me run this. I'm going to change Barbara to a lowercase b. So when I sort, notice that Barbara goes to the end of the list because a lowercase b is greater than an uppercase z. So let's take that case sensitivity out. Go back into our actions. And in the parentheses for our sort method, I'll add array.caseInsensitive. And now I'm going to test again. And when I sort this, Barbara now appears in the list in the correct alphabetical order, even though the B was not uppercase.